Okay, so let's talk about the half reactions, because that's gonna be the whole basis of what we're gonna do today in the lab. So, the whole point of doing half reactions is that you take a complex reaction and you basically break it up into the pieces. So the first thing you gotta figure out is what's being reduced and what's being oxidized. So, on that assignment from yesterday, and this is what you're gonna deal with today. You're gonna have potassium permanganate. You have MnO4, 1 minus. So that Mn here is going to be 7 plus. So in this situation, I tell you specifically that you're gonna end up in Mn2 plus, and that's what's gonna happen in the lab today. So you got Mn2 plus. Now, that has to gain those electrons from something, okay? So in this situation, you've got H2SO3, and that whole thing is sulfurous acid. Sulfuric is a strong acid, that's H2SO4. Sulfurous acid is H2SO3. And you're told that you have hydronium ions, and that just says, hey, it's in an acidic environment. So what you should see is that your MnO4 is what's going to go through the reduction process, which means that that's the oxidizing agent. So your oxidizing agent contains what is reduced. So on that oxidizing agent, you list the entire MnO4. Just don't put manganese, okay? Your oxidizing agent is the entire MnO4. So this is why potassium permanganate, like when we store stuff in the chemical storeroom, we keep oxidizing agents on one shelf and we keep reducing agents on the other side, because we don't want those two mixing together, because then you start uncontrolled redox reactions. So that's why we keep them completely separate. Jacob, it will be convenient at the end of the block.
Do I have to talk about my AP test?
I don't know what,
That's probably what it is.
I don't know. It's just a yellow piece of paper, that's all.
Well, we're trying to figure out the AP weighing test because it falls on
Okay,
graduation.
anyway, shh, anyway, under there. Okay. So your potassium permanganate, and this is why in the lab today, because we're going to be dealing with that, if it gets into your eyes, guess what's going to provide the electrons?
Our eyes.
The cells in your eyes, and that's bad, okay? Very bad. So today, especially, you make sure you are wearing your safety glasses at all times because of the caustic nature of what we're going to be dealing with. So on your oxidation, okay, you've got your MnO4, then on your oxidation is going to contain the reducing agent. So your reducing agent is going to be that H2SO3. So that's kind of a check. So you're on the first one, your reducing agent is the H2SO3, your oxidizing agent is the MnO4. And so, and again, here's why you should really never miss a redox reaction, because you can always check to see if it balances on number of particles and charge. So on that reduction, once you multiply everything through, you should have, this is just the reduction part, you should have 8 waters as a product after you multiply to balance out the electrons. On the oxidation, you should have 5 waters on the reactant side. So you should have 8 waters on the reduction, half reaction. You should have 5 waters over here on the oxidation side. That's why you end up with 3 waters as the product. And again, so when you get done on that final equation, and this is why it is so vital that you write down charges, because that's the only way you can see if everything adds up. Do the sum of the oxidations on one side equal the oxidation numbers on the other? On number 2, when you get done with that one, you should have, on the reactant side, this is your overall equation, 14 hydronium ions And on the other side, on the product side, you should have 7 waters. Okay? Are we cool? Does anybody have any questions? Going once, going twice. Bethany's like, all I see is like this small little face. It's like he's framed. Okay, so get that handed in, and then I'll hand out the lab. So this is probably the longest title of any lab you will have.
You want me to stop this one?
What?
Do you write it like from the second half? Or do you write like the